Hello everyone, my name is Sumedha and today we'll discuss about work. Now from the definition of work, when a force is acting on a body, displaces it, work is said to be done by a force. For example, अगर हमारे पास एक बॉक्स है या एक ऑब्जेक्ट है, हम उस पर फोर्स अप्लाई करते हैं और on applying the force on the object it displaces say distance d, then work will be force applied into displacement. So what is the formula of work? Work is equals to force into displacement of the object. Now this displacement should be in the direction of the force applied. In the direction of force. Now we have two kind of work done. One is for constant force, work done for constant force. That means जो मेरी force act कर रही है object पे वो constant है, that is not changing. Example, again consider a box. मैंने force apply करी in this direction. Displacement हुआ in this direction, say displacement d. Now what will be the work done here? From the formula we know work done is equals to force into displacement. लेकिन अब force की direction तो displacement की direction में नहीं है, इसलिए in this case we'll resolve the components of force. We'll resolve components. This is f cos theta and this is f sin theta. So the component which is in the direction of the displacement will take that component of the force. So here work done becomes f cos theta into displacement. Work done is equals to fd cos theta. So this is a work done for a constant force. Now let's see work done for a variable force. That means जो मेरी force act कर रही है वो vary कर रही है either in magnitude, either in direction or both magnitude or direction. We'll consider like this, say point P1 and point P2. We have to calculate the work done in moving object from point P1 to P2. यहाँ पे force की direction vary कर रही है. So in this case what we'll do, we'll divide this into very small infinitesimal parts and we'll take one part, say that is dr, and we'll calculate work done for this part such that for this part the force acts to be constant or we can assume force to be constant. So for this we'll get dw is equals to force into dr. Now we get work done of this part. Now we'll integrate dw and f dot dr from point 1 to point 2 and we'll get work done is equals to integration from point 1 to point 2 force into displacement. So this is my work done when a force is variable. Now let's see what is the nature of work done. Nature of work done. We have positive work done, positive work done, negative work done, and zero work done. Let's discuss all these three natures one by one. Positive work done. Now from the formula of work done, force is equals. Now from the formula of work done is equals to force into displacement. तो पॉजिटिव वर्क डन कब होगा? When the force applied in the direction of the displacement. That means when the displacement takes place in the direction of applied force. In this case, work done will be positive. Or what we have, work done is equals to FD cos theta. For theta less than 90 degree, my work done will be positive. Now negative work done. Again, work done is equals to force into displacement. When the displacement takes place in the opposite direction of force, then the work done is said to be negative. For this, theta is greater than 90 degree. इसका एग्जाम्पल क्या हो सकता है? Example, work done by frictional force. फ्रिक्शनल फोर्स में क्या होता है? फ्रिक्शनल फोर्स एक्ट्स इन द ऑपोजिट डायरेक्शन ऑफ डिस्प्लेसमेंट. और अनदर एग्जाम्पल कैन बी वर्क डन बाय द ब्रेक्स ऑफ कार, by the brakes of car when we stop a car. And positive work done ke there are many examples. We can consider the same example. A box is there and we apply a force and the box displaces in the same direction of the applied force. So this is an example of positive work done. Negative work done. Now let's discuss zero work done. Work done is equals to force into displacement cos theta. For work done to be zero, either force is zero, displacement is zero, or theta is 90 degree, because cos 90 is equals to 0. इसके examples क्या रहेंगे? Pushing a wall, pushing a wall. When we push a wall, हम force apply कर रहे हैं लेकिन displacement is 0. In that case, work done will be 0. Second, a particle is moving in a circular motion, with uniform velocity. पार्टिकल है, सर्कुलरली मूव कर रहा है, सर्कुलर मोशन में वेलोसिटी विल बी टेंजेंशियल, फोर्स इनवर्ट्स, सो एंगल क्या हो गया? 90 डिग्री. cos 90 0, work done will be 0. So these were the three natures of the work done. Now let's talk about units and dimension of work. Units. SI units of work is joule. 1 joule is equals to 1 Newton into 1 meter. That means when a 1 Newton force is applied and displacement of 1 meter takes place. That define 1 joule of work. Now dimensions are m, L square, T minus 2. These are the dimension and these are the units of work. Now let's solve some numerical problems on work. A body of mass 20 kg is at rest. A force of 5 Newton is applied on it. Calculate the work done in the first second. Now we are asked to calculate work done. Work done is equals to force into displacement, and we are given mass 20 kg and force 5 Newton and time 1 second. So now from here work done is equals to force into displacement. Equation 1. We know displacement is equals to ut plus half at square. Displacement is equals to u. Initial velocity is 0 because the object is at rest. 0 plus half a. Time is given 1 second. So I'll get distance is equals to half into a. Now we know force is equals to mass into acceleration. Therefore acceleration is F upon m. Therefore distance is equals to half F upon m. Say equation 2. Substituting the value of d into 1, we'll get work done is equals to force into half F upon m. Here work done is equals to F square upon 2m. Force is 5, 25, mass is 20, 40. 5 upon 8 joule. So this is the work done. A position dependent force F is equals to 7 minus 2x plus 3x square acts on a small body of mass 2 kg and displaces it from x equals to 0 to x equals to 5 meter. Calculate the work done. We are given with the force. This is a variable force. Force is depending on x, and what we have given in a numerical, x goes from 0 to 5 meter. So we'll use formula of variable force. Of work done by a variable force is equals to integration f dot dx. Now integration is from 0 to 5. Work done is equals to 0 to 5. Substituting the value of force, 7 minus 2x plus 3x square dx. Work done is equals to 7x minus 2x square upon 2, 3x cube upon 3. I have just done integration and now I will put limits. 2 cancels with 2, 3 cancels with 3. On substituting the limits, I will get 7 into 5 minus 5 square plus 5 cube from this, which is equals to 35 minus 25 plus 125, which is equals to 135 joule. So this is the work done by this force. Now after discussing about work, let's discuss about energy. Internal capacity to do work is called energy. We have different types of energy: electrical energy, mechanical, sound energy, etc. Energy of one form can be converted to another form. Our basic stress on this chapter will be on mechanical energy, which have further two types. One is potential energy and kinetic energy. Before moving to mechanical energy, let's discuss energy mass relation. Energy mass relation, that is E is equals to mc square, where E is the energy, m is mass and c is speed of light. Units of energy is joule and dimensions ml square T minus 2. So this was the brief introduction to energy. Now let's move to kinetic energy. So now kinetic energy, from the definition, kinetic energy is the internal capacity of doing work by virtue of its motion. That means kinetic energy is related to motion. The formula of kinetic energy is half mv square. M is the mass and v is the velocity of the particle. Now let's discuss about work kinetic energy theorem. What this theorem states that work done by all the forces acting on a particle is equal to change in its kinetic energy. For example, अगर मेरे पास कोई पार्टिकल है, उस पे जितनी भी फोर्सेस एक्ट कर रही है, से F1, F2 और F3, तो जो पार्टिकल पे जितनी फोर्सेस एक्ट कर रही है और जो वर्क डन कर रही है, दैट विल इक्वल टू द चेंज इन काइनेटिक एनर्जी. Work done is equals to delta of kinetic energy. That means final velocity of the object half m, final velocity of the object minus half m, initial velocity of the object. Now let's prove work energy theorem. For that we consider a diagram. Mass m with initial velocity u displaces some distance, say s, and moves with velocity v, and force is applied. Now we know v square minus u square is equals to 2as, equation 1. Also, force is equals to ma, therefore acceleration is equals to f upon m. Substituting the value of a into equation 1, v square minus u square is equals to 2 f upon m into s. Now I'll take mass this side, mass v square minus u square, and 2. This will give me f into s. Now what is my force into displacement? Work done, I can write it w. So I'll get w is equals to m v square minus u square upon 2. Work done is equals to half mv square minus half m u square. That means change in kinetic energy. Work done is equals to delta of kinetic energy. This was the work energy theorem when force is constant. Now let's discuss about variable force. If force is variable, then work done is equals to integration f dx. Work done is equals to, we know F is equals to ma, substituting ma dx. Acceleration को I can write v dv upon dx to dx. So work done will is equals to mv dv. Limits are from u to v, that means initial velocity to final velocity. I'll get work done is equals to m, because mass is constant. Integration of v is v square upon 2 u to v, and I'll get half v square minus half u square on substituting the limits, which is equals to half mv square minus half mu square. That is change in kinetic energy. So this was for the constant force and this is for the variable force. So this was all about work and energy. We'll see you in the next video. Till then, keep revising.